I've done a range from 225.
Gives a wave, Joe.
And that's very thoughtful of you, but you don't only because you get but it's good.
Well, thanks, isn't it? I don't know what else to do with that.
Right, so what we're doing today is, before we start measuring your compounds, we have to do a process called blanking. Okay? The reason for that is you've diluted your solutions in water, but water also absorbs light as well. So you need to subtract the water away from your solutions. Okay? So we'll do blanking first. So we take water, just normal tap, not that water, distilled water. Okay? We get all the cuvettes up. So the first one is to rinse it. Okay, and then the second one. So.
When he goes over there, you've got to do something entertaining.
Before you inject it, it doesn't matter right now. It doesn't matter. Right, okay, so what we do is pour it in and then just.
And this is the one that's clear on all sides, and so you have to be careful.
Yeah,
oh, it's
You're
not.
blanking that with water.
Yeah, just normal distilled water. Okay. Right, so this is where you put your cuvette. Okay.
Okay, that's silver one.
So that's the window.
Okay.
So the light comes from here, hits your sample, comes out, and then there's a detector on the other side.
Is this a multifunctional machine? It's got two windows.
Yes, it does. I'll come to that in a minute.
Where do you put a cuvette?
Put in the first one.
Oh, right.
The clear side must face the window. Okay, so, or the cloudy side face you. Okay.
So you can put lots of cuvettes in there at a time?
You can, yeah. It doesn't work anymore. You used to be able to put a lot in there. There's a little motor here that moves it up and down, but that's busted.
So we have to do it individually?
Yes. But you've got plenty of time. So
that's right.
Okay. Right, so what happens is, you've got your light that comes from here. Okay, it bounces off here. There's
Light.
Yes. There's a mirror somewhere around here.
Mirror.
The mirror moves left and right, so that will give you your wavelengths. Okay. When it gets to roughly about midway here, there's a beam splitter. Okay, and it splits the light into two. Yeah. So 50% of the light goes through the first window, 50% of the light goes through the second window. Okay. So because of that, this is called a dual beam UV spectrophotometer. You can get single beam ones, in which case you have.
They're the ones we use upstairs.
Yeah, the ones you have to keep swapping out in and out. Okay. This one, the top one is called a reference. Okay, so that always stays there. Okay. The second one, on the bottom, is called the sample. Yeah. So what it does is it measures both of them simultaneously, and then it subtracts this one from that one. Whereas upstairs you have to physically swap it out in and out. This way you don't have to. It does it for you. Okay. Right. So first of all we do the blank. So again.
So this is the first one we get.
Yeah. So you don't actually write this down. Okay. So make sure it's nice and clean and there's no air bubbles in there, okay? Because air bubble does obstruct the light. So
there's a little bit of
just give it a flick.
So for the quinine in tonic water, when that's been read, would air bubbles in that and the beer in the would that affect anything?
It would. It depends how big the air bubble is. If it's
the ethanol one.
But if you didn't degas your beer or your tonic water, would that have made a difference to the results?
Are your results really bad?
No, they're really
fine,
good.
Yeah. If it's good, then I'll leave it as that. Yeah.
But you could put that. It could be a source of error.
You could do. You could put some. Yeah. Because someone.
We probably haven't because we were.
Yeah.
Sorry, moving on.
Yeah. Obviously, you can always put down tiny air bubbles that you can't see.
Yeah.
And maybe the fluctuation.
But then you could put because our results were really linear and very similar in result.
You had no air
That we had no air bubbles because we can see that the level of accuracy was high.
Yep. No, absolutely. Right, close the lid, and then can you come this way and you get right the PC? Right, can you click an auto zero? Which is the one just. Yep.
This is one of these moving
Ask
shots.
you to put the blank in. You've already done that.
Yep.
Yeah, just click OK. Okay. The way it does now, it scans from 550 to 220.
Okay.
Any spectrum it picks up now, it's just going to call it 0.
Okay.
Okay. So just let it finish.
So it's going to go right the way down.
Yeah, so when it finishes, the red button will disappear, and then you know you can take it out.
Okay.
And you set that purposely.
Yeah. So this is the result I'm expecting you to get. Okay. Your result has to be somewhere within this range. If it's too high or too low, then you never repeat it. Okay? Only because you need his results for next week. If it's wrong this week, it'll be wrong next week.
Okay.
Okay? So this is an overlay of all 4 of your compounds.
Sorry to interrupt.
So-
Steve's got a really quick question for you.
Yeah, sure.
Steve Jones.
Yeah.
Do you want me to carry on?
Oh, yeah, if you could, yeah.
So where does he get to?
We want to get this result so that next week we won't cook everything up.
So that's your concentration.
Blanking at the minute.
Yeah, it's blanking.
You are on camera. I hope you realise this.
Oh no! Thanks. I've already been
You look
filmed.
beautiful.
Oh no, I don't. Okay, so he's explained to you the linear relationship between absorption and concentration at
Not
any
yet, no.
single given wavelength.
No,
Oh, I
not
thought
yet.
that's where we're getting to, because he was saying your samples need to look a bit like this. Is that what he
Yeah,
said?
he said that, but he didn't explain why.
Right, that's why. It's okay.
Okay.
So this one, you can see, if you look in red, is the tartrazine
Okay.
spectra. So all those wavelengths have been scanned through the tartrazine and seeing which of those wavelengths have been absorbed.
Okay.
And you can see that it absorbs the most of the wavelength 428, but it's also got another peak at 258.
Okay.
Alright, so it absorbs the most of that. Now that is an example of tartrazine at 25 micrograms per centimetre cubed. And that absorbance level, that wavelength, is 0.738, yeah?
Okay.
There's no units to that, it's just a level of absorbance.
Okay.
If your sample was 50 micrograms per centimetre cubed, so double the concentration, then that absorbance level doubles. So you would get a value of about 1.78.
Yeah.
0.738,
Okay.
yeah. So what he's saying is you've got to check at the peaks that the absorbance is roughly or close as possible to these ones. Yeah? To make sure your concentration dilutions are correct. So it's best to spend the time practicing and getting that right this week, because you've got an awful lot of dilution